Hi, welcome to this video. In it, we'll look at primarily the questions where you have to prove that two vectors are parallel to each other or that they're on the same straight line. This seems to be a really popular style of question for like the harder end of the GCSE style vector questions. So let's dive in with this other type of popular question, where you need to sort of combine some basic shape knowledge with working out a vector. So here we've got a regular hexagon, that'll be important in a second, and we are just told these two vectors. We are then asked, what is a vector from x to w? And at first glance, that's not obvious what to do. We can fill in that these vectors must be a or b. Again, it's a regular hexagon, so everything's going to be the same top and bottom and side to side. But it doesn't help us work out x to w. The important thing of regular hexagons is that these angles inside are 120 degrees. And if I extend these lines off here, we can see these are both going to be 60 degrees. That's important because that means that what I've just drawn here, this is an equilateral triangle, which means if this is vector B, then so is this. And if this is vector A, then so is this. Now we can work out x to w. We can go from x to w by going along this path. And we can see, again, checking the arrows to point the right way, that is just going to be vector A minus vector B. Okay, next part is find the vector y to v. Okay, this one's not too bad now. All we need to do is just go along, I'll just do this path anyway. And we can see that's going to be 2a minus 2b. Okay, and this shows something quite important. So as we can see, the vector yv is basically double the vector xw. If we have this case, where you can say that one vector is double, triple, or 2/5 or whatever of another vector, that therefore proves those two vectors are parallel. So the main proof to prove the vectors are parallel or on a straight line is by factorization, to show that they factorize with the same stuff on the inside. Whenever that happens, you have proved two things are parallel. Okay, so that's the key idea. So looking at these three vectors, if you want to show which are parallel, the way you would do it is you would factorize them. So top one, that cannot be factorized. This one here, I have a common factor of 3. So it'll be 3, 2a minus 3b. Here I have a common factor of 2, so it'll be 2, 2a plus 3b. And any vectors are parallel if they have the same thing inside the brackets. So these two vectors are parallel, but this one wouldn't be because there's a plus there rather than a minus. Okay, that's a key idea we're going to go through in this video. So let's go through a few examples just illustrating that idea. So first point, we need to work out a vector mn. So vector m and vector n are both there. Those are 2 points. And let's see what we're told. We're told that from A to C, here to here is going to be 2a, and that's pointing in that direction. And A to B is going to be 3b. Let's see what we know. We know that M is the midpoint of AC. That tells me that this vector is A, and this vector is also A, because it's the midpoint, so 2a splits in half. And we need to work out some vectors around point N. So we're told that B to N and N to C are in the ratio 2 to 3. That adds up to 5, which means this length will be 2/5 of the whole thing. So Bn will be 2/5 of BC, and let's work that out. BC we can get by taking this route. So it's going to be 2/5 from B to A is minus 3b, and from A to C is plus 2a. Okay, so now we're getting somewhere. We have the vector Bn, let's add that on with a little arrow. That was whatever I got there. Now what we need to do is we need to work out the vector m to n. So the path I can now take is this path here. So let's work out all those legs. So from M to A, let's write this down. So if you find harder questions, one way to make it feel a bit easier is just really write down your steps. in terms of exactly which route you are taking to get from M to N. Again, you don't have to do this, but for me personally, it makes life a bit clearer. So M to A is going to be minus A, because we're going against the arrow. A to B is going to be 3B, and B to N we have, that's going to be 2/5 of this. And again, like most questions, this one asks us to put it in its simplest form. So we need to combine all our A's together. So here I've got minus A, and here I've got 4/5 A. So I'm now left with minus 1/5 of A. We then have 3B plus or minus 6/5 of B, which means I'm going to be left with 9/5 of B. Okay, so that's done there. Then part B. Use your answer to part A to explain why MN is not parallel to AB. So we know the vector AB was just 3B, whereas this vector equaled this thing here. So because we can't factorize this into this form, they are not parallel. Or we say in more succinct form, because this has some A involved in it, it's not going to be parallel to B. Okay, that's kind of the basic idea. Let's go through a few more common examples. So these are some more typical exam style questions. So first part, I've got something fairly straightforward. We need to work out the vector from P to B. I'm going to go this direction. We can see here, I go minus B backwards, minus 2B backwards, and then A forwards. So that's going to be minus 3B plus A. Okay, then on to the main idea. We then need to prove that NMC, so this is a straight line. Okay, so let's add in some vectors. We've got some information here. First, we are told that B is the midpoint of AC. So it tells me B is the midpoint of AC. So if this length is A, this must also be A, because B is the middle of AC. We are told M is the midpoint of PB. Okay, again, that's useful. We know what PB is. So PB is this fella here. So that means each of these is going to be half of that. Again, that's a vector PB, which points from P towards B, so we're going to be in this direction here. Okay, to show that NMC is a straight line, what I'm going to do, I'm going to work out the vector from N to M, and then the vector from M to C. And I need to show that those two things are parallel to each other. If they're parallel, and they both include the same point, then they must be on a straight line. So to go from N to M, I'm just going to take this path here. So that will equal, that's going to be going from M to P, and then going from P to M. So N to P is B, P to M is a half minus 3B plus A. That simplifies down to minus a half plus a half A. So minus half B there. And we can factorize this. We can take out a factor of a half. So it's a half minus B plus A. So what I'm looking for is when I work out M to C, it should factorize to something with a minus B plus A inside the brackets. So M to C, I'm going to head up this route now. So that is going to be from M to B, and then from B to C. M to B is 1/2 minus 3B plus A, and B to C is just A. Adding those together, we can see we're going to get minus 3/2B plus 3/2A, which looks very good. We can take out a factor of 3/2, so I'm left with minus B plus A. And if I compare that, we can see that both these two things are the same. And that proves it. Okay, you would then say, because these vectors both have the same terms in the middle of the factorized brackets, they must be parallel, which therefore means NMC is a straight line. Okay. Another question showing that same idea. So again, we're going to have a fairly nice normal part A. Just find the vector O to S. So let's do that now. So O to S, I'm going to want to take this route here, I think. Problem is, I don't yet know what Q to P is. So let's work out Q to P. I need to go this way than this way. So that's going to be minus q plus p. We are told that s is this midpoint, so therefore this length from q to s will just be half of that. So a half of minus q plus p. Therefore O to s, like I said, it's going to be this route here, is going to be q plus 1/2 of minus q plus p. Simplifying that down, that's just going to be a half q plus a half p. Okay, next idea, or next question, we need to show that RS is parallel to OQ, and R is also the midpoint of OP. So we know OP, this whole length was P, which means this section is going to be half P, and this section is also going to be a half P. So let's work out the vector from R to S. Let's go from R to S, same as before, I just need this length here. So it's going to be go from R to O, and then go from O to S, which I've just worked out in part A. So going from R to O is just minus a half P, and going from O to S, we have over here, is a half Q plus a half P. Simplifying that down, these two cancel out, I'm just left with a half Q. Okay, and we can see from here that OQ is just Q. And we can basically say from there, therefore these vectors are parallel. And that's the basic idea. So the key thing is, whenever they're parallel, you must show one as a multiple of the other. Okay, occasionally you'll see it written, you'll say that OQ is double RS, which also shows they're parallel. So a few ways you can write it down, but the key thing is showing those two vectors the same, showing they have basically the same terms involved. Okay, I hope that helped, and good luck.